Multidimensional Expressions is a query language for OLAP databases, much like SQL is a query language for relational databases. It is also a calculation language, with syntax similar to spreadsheet formulas. Background: the Multidimensional Expressions language provides a specialized syntax for querying and manipulating the multidimensional data stored in OLAP cubes. While it is possible to translate some of these into traditional SQL, it would frequently require the synthesis of clumsy SQL expressions even for very simple MDX expressions. MDX has been embraced by a wide majority of OLAP vendors and has become the standard for OLAP systems. History: MDX was first introduced as part of the OLADB for OLAP specification in 1997 from Microsoft. It was invented by the group of SQL Server engineers including Moshe Pasumansky. The specification was quickly followed by commercial release of Microsoft OLAP Services 7.0 in 1998 and later by Microsoft Analysis Services. The latest version of the OLADB for OLAP specification was issued by Microsoft in 1999. While it was not an open standard, but rather a Microsoft-owned specification, it was adopted by the wide range of OLAP vendors. This included both vendors on the server side such as Applix, ICCube, MicroStrategy, NCR, Pentaho, Oracle Corporation, SAS, SAP, Teradata, Symphony Teleca, Active Pivot and vendors on the client side such as Panorama Software, Pentaho, PowerOLAP, Xcubed, ProClarity, APP Source, Jaspersoft, Cognos, Business Objects, Brio Technology, Crystal Reports, Microsoft Excel, Tagetik, and Microsoft Reporting Services. With the invention of XML for analysis, which standardized MDX as a query language, even more companies, such as Hyperion Solutions, began supporting MDX. The XML for analysis specification referred back to the OLADB for OLAP specification for details on the MDX query language. In Analysis Services 2005, Microsoft has added some MDX query language extensions like subselects. Products like Microsoft Excel 2007 have started to use these new MDX query language extensions. Some refer to this new variant of MDX as MDX 2005. MDXML . In 2001 the XMLA Council released the XML for Analysis standard, which included MDXML as a query language. In the current XMLA 1.1 specification, MDXML is essentially MDX wrapped in the XML tag. MDX data types: there are 6 primary data types in MDX. Scalar. Scalar is either a number or a string. It can be specified as a literal, for example number 5 or string OLAP, or it can be returned by an MDX function, for example aggregate, unique name, value etc. Dimension hierarchy. Dimension is a dimension of a cube. A dimension is a primary organizer of measure and attributes information in a cube. MDX does not know of, nor does it assume any, dependencies between dimensions. They are assumed to be mutually independent. A dimension will contain some members organized in some hierarchy or hierarchies containing levels. It can be specified by its unique name, for example, time, or it can be returned by an MDX function, for example dimension. Hierarchy is a dimension hierarchy of a cube. It can be specified by its unique name, for example, time. Fiscal, or it can be returned by an MDX function, for example hierarchy. Hierarchies are contained within dimensions. Level. Level is a level in a dimension hierarchy. It can be specified by its unique name, for example, time. Fiscal. Month, or it can be returned by an MDX function, for example level. Member. Member is a member in a dimension hierarchy. It can be specified by its unique name, for example, time. Fiscal. Month. August 2006, by qualified name, for example, time. Fiscal. 2006. Q3. August 2006, or returned by an MDX function, for example prev member, parent, first child etc. Note that all members are specific to a hierarchy. If the selfsame product is a member of two different hierarchies, there will be two different members visible that may need to be coordinated in sets and tuples. Tuple. Tuple is an ordered collection of one or more members from different dimensions. Tuples can be specified by enumerating the members, for example, or returned by an MDX function, for example item. Set. Set is an ordered collection of tuples with the same dimensionality, or hierarchicality in the case of Microsoft's implementation. It can be specified enumerating the tuples, for example, measures. Sales, time. Fiscal. 2006, or returned by MDX function or operator, for example cross-join, filter, order, descendants etc. Other data types. Member properties are equivalent to attributes in the data warehouse sense. They can be retrieved by name in a query through an access properties clause of a query. The scalar data value of a member property for some member can be accessed in an expression through MDX either by naming the property or by using a special access function. In limited contexts, MDX allows other data types as well. For example, array can be used inside the setToArray function to specify an array that is not processed by MDX but passed to a user-defined function in an ActiveX library. Objects of other data types are represented as scalar strings indicating the object names, such as measure group name in Microsoft's measure group measures function or KPI name in, for example, Microsoft's kpivalue or kpgo functions. Example query: the following example, adapted from the SQL Server 2000 books online, shows a basic MDX query that uses the select statement. This query returns a result set that contains the 2002 and 2003 store sales amounts for stores in the state of California. In this example, the query defines the following result set information. The select clause sets the query axis as the store sales member of the measures dimension, and the 2002 and 2003 members of the date dimension. The from clause indicates that the data source is the sales cube. The where clause defines the slicer axis as the California member of the store dimension. Note: you can specify up to 128 query axes in an MDX query. If you create two axes, one must be the column axis and one must be the row axis, although it doesn't matter in which order they appear within the query. If you create a query that has only one axis, it must be the column axis. The square brackets around the particular object identifier are optional as long as the object identifier is not one of reserved words, does not otherwise contain any characters other than letters, numbers or underscores. The members function returns the set of members in a dimension, level or hierarchy. References. External reference: George Spofford, Sivakumar Maharanath, Chris Webb, Dylan Hai Huang, Francesco Savardi, MDX Solutions, with Microsoft SQL Server Analysis Services 2005 and Hyperion S-Base. Wiley, 2006, ISBN 0-471-74808-0, Moshe Pasumansky, Mark Whitehorn, Rob Zer, Fast Track to MDX. ISBN 1-84628-174-1, Larry Sackett, MDX Reporting and Analytics with SAP NetWeaver BW SAP Press, 2008, 978-59229-249-3, MDX reference from SQL Server 2008 books online, MDX reference with live examples from ICCube, MDX Gentle Tutorial, MDX Essentials series by William Pearson in the Database Journal, MDX Video Tutorial.